All right, so today we're going to talk about exponent rules. And we're going to be dealing with multiplying exponents together. So first you need to remember the basics. So if you have something such as 2 to the third power, you need to remember that does not mean 2 times 3. This right here is your base number. And this, of course, is your exponent. And this means, of course, you've got 2 times 2 times 2. So if you were to evaluate, you would, of course, say that that's 8. Okay, but there's your basics of exponents. We're going to go ahead and talk about some of the rules that they have with exponents. So here's your first rule. Now they call this the product of powers. All right, so I'm going to leave a little blank here that we're going to fill in. So I want you to think about and see if you can figure out what this rule is. I'll give you a little bit of an example. Let's say you have x to the third power, and you want to multiply that by x to the second power. Now, if you want to do this longhand, x to the third power is going to get you x times x times x. All right, so there's the first part. Then you want to multiply that by x to the second power, so you have x times x. There's your second part. So look at how many x's are now being multiplied together, and you have x to the fifth power. So basically, if you look at your original powers here, all you did was add them to get the exponent in your final answer. So here's how that rule is going to look. Let's say you have any number or variable raised to a power. You need to take that same base number, so the base numbers have to match. And let's raise that to a power. In your answer, keep the same base number and add your exponents. So the key here is the base numbers need to be the same for this rule to work. Okay, same base number. All right, then the second rule that you're going to see is a power of a power. All right, so I'm going to go ahead and leave a box here. We're going to fill that in with the rule. And let's see what that's going to look like. So if you have something like x to the third power, and then you're squaring that, that means you have x to the third power being multiplied by itself. That's squaring something. Whoops. So if we write that out longhand, we've got 1, 2, 3. There's the first x to the third and another one. So there's x to the third times x to the third. We have 6 of them being multiplied together, so we could shorten that to x to the sixth power. So if we go back to the original problem, we can see here that if we had just multiplied our powers, we would have had our answer. So in this example, I had one base number, and it was being raised more than one time to a power. So each of these powers went to the same base number. This rule over here, each of the exponents had its own base number. That's when you're adding. So if we write the rule out, a base number to a power, but then immediately raise it to another power, you keep the same base number, you're going to multiply your two powers together. So that's the second rule that will apply. Now you can take this a step further. Let's say you have more things going on in your parentheses. So let's say you have A times B, and that is being raised to a power. Now you can have exponents here, or if nothing is there, you have ones. You are still multiplying as long as you have a product inside. Now if you're adding A and B, this rule does not apply. But if you're multiplying inside, then you continue with this rule of multiplying your powers, but you go to each base number. So A is a base number, so you multiply the powers here, m times 1, and then you have go to your second base number and multiply your powers there. So that just kind of extends this rule that we have up here. So an example like this here, this extension, let's say we had 2a to the third b squared, but I wanted to raise all that to the third power. So this exponent out here goes to all the powers you see inside, but what you need to remember is that this coefficient has a power of 1. So you have 3 exponents on the inside. So you're going to multiply the 3 by the 1, the 3, and the 2. And you'll have 2 to the third power, then a will be to the 9th power, and b will be to the 6th power, and you can of course simplify that 2 to the third power to be 8. And that would be the final answer for that. So let's do some more examples using both of these exponent rules. All right, we'll start with that first rule. And I'm going to show some detail here that you can put in your notes. All right, you basically have 1, 2, 3, 4 things here being multiplied together. Now remember, the commutative property says you can move these items around. Multiplication is commutative. So take your coefficients. You've got 6 times 2. And then you're multiplying the n to the third by n to the 7th. So when you take care of that, your new coefficient becomes a 12. And with your n's, remember, you're going to take the 3 plus 7. Each of the powers gets their own base number. That is when you're adding. You've got 3 of them here, 7 of them here. You've got 10 altogether. So your answer would be 12n to the 10th power. All right, if you have something like this, I'm going to do the same thing that I did up here, keeping in mind that you have a coefficient here of a 1. So you are technically multiplying your coefficients together, so it will remain a 3 in your final answer. And then don't forget, the p's can be multiplied together. That is p to the first. It's very common to forget to put a 1 here and keep your final answer as p to the third power. But you need to remember you have an exponent of 1 right there, and you're going to add the 3 and the 1. For the t's, t to the third, and then t to the fourth. So when you put all that together, your new coefficient, if you multiply, stays a 3. P is now to the 4th power, and the t, when you add your 3 and your 4, to the 7th power. All right, let's say we have something with a few more variables in it. Okay. Now you don't have to rewrite everything like we've been doing here, but just keep in mind that's what we're doing. So if you take a look at your coefficients, you've got a -4 and a -6. they get multiplied to be your new coefficient. So that's going to get you a 24. And then just go alphabetical with your variables. You have an r. Don't forget, that's r to the first. So you end up with r to the 6th power by adding your exponents. So all of these are using that first rule I've shown you in the notes. For your x's, you have a 2 and a 2. You have x to the 4th. And your t's, when you multiply those out, please remember you have a t to the 1st power there, so that is t to the 4th. So basically, you've got the problem. You can go straight to the answer if you've got a good understanding of this. All right, let's change up our rule. Let's go to that second rule that we wrote in the notes. All right, let's say you have something like this. We could keep on going, raising that to a power. You don't have to take the inside first, although you could. Now we're multiplying 3 times 2, which is 6. And then that 6 would get multiplied by that 3. So basically you are taking the same base number. You do not change the base number. You're multiplying all your powers. All of these are going to that same base number. That's when you multiply. So you have 2 times 3 times 3. So you have 3 to the 18th power. Now it's not saying evaluate, it's saying simplify. So you would keep it in that form. All right, let's raise all of that to the 4th. So this exponent goes to all the base numbers inside. Keep in mind that -3 is being raised to a power as well. It would become a negative base number, so you need to have that in parentheses, and you're taking 4 times 1. -3 is being raised to the 4th power. The coefficient is being raised to that outside power as well, so don't leave that out. For the p, you are multiplying the 5 times the 4. And for the t, you are multiplying the 6 times the 4. So you could clean your answer up. -3 times -3 times -3 times -3. 1, 2, 3, 4. You have 4 negatives. That's going to be a positive 81. P is being raised to the 20th power, and t is to the 24th power. All right, let's try one where we mix all the rules together. This will be our last example. It's a z. All of that's to the 3rd power. When you have a problem like this, you need to make sure you take care of all the outside exponents first. So inside, I make sure I give every one a power, so I now know to multiply by every power. That is 5 to the 2nd power, and 2 times 2, x to the 4th power. This set has a power on the outside, so we need to use our multiplying rule, not forgetting the coefficient. 3 times 1 makes that 2 to the 3rd. X is to the 1st, so when you do 3 times 1 again, x is to the 3rd. Y would be to the 9th when you multiply, and the z has a 1. Z would be to the 3rd power. This does not have an exponent on the outside, so I'm just going to bring this down as is. Now we're going to go ahead and use a different rule because every exponent here has its own base number. This is a 1, this is a 1, this is a 1. This is when you add your powers, but it's only putting like bases together. So if I take my coefficients, 5 squared is 25. 2 to the 3rd would be an 8. They all get multiplied together. And then you have your 4. So I'll multiply that out to see what my new coefficient is. For the x's, go on down the line. You have a 4 and a 3, so that's 7 so far, and a 1. You have x to the 8th power. y would come next. We don't have a y here, but there's a y to the 9th. And don't forget that's a 1, so you add those together, you have y to the 10th. And your z's, there's a 3, and that z has a 1, z to the 4th. The only thing I would do is clean that up. If you multiply your 25 and your 4 together, that's 100 times the 8. You can do that mentally. Bring everything else down. All right, so go back and listen to anything that you need to again. Bring your notes to class. We'll go over any questions that you have.